Hello students. Today we will be starting the next topic of limits and derivatives, that is derivatives. We have done limits. In the first video we discussed about what is limit and types of the sums which come under limit. In the second video we discussed exercise 13.1. Now in the third part of chapter 13 we will be discussing about derivative. Now children, what is derivative? So let us first understand what is derivative. We will be doing derivative. So derivative, so one definition we can say that derivative is rate of change of one quantity with respect to another. And the second definition or the second meaning we can say that derivative is slope of a tangent. Slope of a tangent. Now let us first understand what is slope. Now slope is, as you have done in other chapters, the conic section chapter also, as well as in standard 10 also you are knowing about the slope. So what is actually slope is the angle made by a line with the positive direction of x-axis. So suppose this line makes some angle with the x-axis. So the angle or the inclination is called the slope, we can say. What is tangent? So tangent, a line which touches an arc or a circle at exactly one point is called tangent. So slope of this tangent is called derivative. Now let us understand the formula for the derivative and the definition of the derivative. Now before understanding the derivative, one concept which you have done earlier is, I think in conic section you have done, suppose this is a secant and is intersecting this curve at 2 points, suppose x1, y1 and over here x2, y2. Okay? Now this point is suppose p x1, y1 and q x2, y2. Now to get the slope of this line, we are knowing that slope of, suppose this is line L, from conic section we have done, slope of line L equals to difference of the y coordinates divided by difference of the x coordinates, which we have already done and which we are knowing. So this we also use to write tan theta if this theta is known. But if the 2 points are known, then the slope of this tangent, the slope of this line is y2 minus y1 divided by x2 minus x1. Now to get the slope of a tangent, how we will get? Because tangent is intersecting this curve or the circle if we consider at exactly one point. Now we are knowing the slope of a line which intersects the curve or which touches the curve at 2 points is difference of the y coordinates divided by the difference of the x coordinates. Now how to get the slope of a tangent? So let us understand it properly. So let us now get the slope of, try to get the slope of a tangent. Now, since our mathematicians defined how to get the slope of a line which intersects a curve at 2 points, and they defined it as difference of the y, slope of that line is difference of the y coordinates divided by the difference of the x coordinates. Now, to get the slope of the tangent, what we will do is, suppose we are considering over here a point, suppose P x y. Okay. Now I have to consider one point just close to pxy in such a way that the distance between the point, that is, let us suppose over here q x1 y1. Now this point q is so much close to p that the distance, if we consider the distance along the x-axis as well as along the y-axis, we can consider that distance, this distance, to be so small, so infinitesimally small, so that we can consider that distance to be almost zero. That is, suppose this distance is 0.000001. So obviously this is so close to the, that is, the points P and Q are so close, so that the distance between them we can consider as tending to 0. I think now you got the point. So, but we have got 2 points. Now we can get the slope of this tangent because these 2 points are so much close to each other. Over here you can see these points are so much close to each other, so that if we draw tangent to these 2 points, then they will almost coincide each other. That is, the tangents to these 2 points which are so much close to each other will be, means, to some extent coinciding each other. So in this case we got a tangent also and 2 points also. So let us redraw the figure and understand the slope of this tangent. So suppose this is our curve, this is the point. Suppose over here this distance is this much, from here to here it is x, and from here to here it is fx, this y value. So over here we will write the coordinate as x comma fx. This for y we are writing fx, y equals to fx over here. Now the point which is infinitesimally small distance with P and very close to P, that we are supposing over here, so that you can understand the figure, and it is very close to P, just that only you understand. So Q, let us over here write, and this distance, let us write this fx over here. This distance which we are taking very small, let us take it h. Okay? So over here the coordinate of Q we can write as x plus h, and accordingly y coordinate is f of x plus h. Okay? So that when we are drawing tangent, it is almost same, one tangent is coming for both the points. Okay? If you want to understand for y, the distance, this distance is h. Okay? So the slope of this tangent, slope of the tangent will be equals to difference of the y coordinates, that is f of x plus h minus of fx divided by difference of the x coordinates, x plus h minus of x. Now over here this h is so much small that we can write h is tending to 0. That is, in the limiting case h is tending to 0. So we can write over here that limit h tends to 0. H is very small, it is 0.000001, so it is tending to 0. So slope of the tangent we can write as limit s tending to 0 f of x plus h minus fx divided by x plus h minus of x, difference of the y coordinates. This x is cancelled and we are getting this slope of the tangent as limit s tending to 0 f of x plus h minus of fx divided by h. And this only is the definition of derivative of fx. So this derivative of fx we write as fx dash or f dash x. We write this as, we read it as f dash x. So f dash x equals to limit s tending to 0 f of x plus h minus of fx divided by h. Now if we write y equals to fx, then this derivative of y we also write as, let us write here, if y equals to fx, then derivative of y is written as y dash or f dash x. Okay? Now Suppose derivative of z we have to find. The derivative of z is z dash. Derivative of t we have to find. Then we write it as t dash. So I think now you understand. Now over here, if the variable is x, then the derivative of y with respect to x we find. So derivative of y with respect to x is written as dy by dx. dy by dx, or we read it as d by dx of y. So we can write dy by dx equals to y dash equals to f dash x. I think now you understand. Now over here, if we again differentiate it twice, means this first time, this is the first time derivative. If you want to means differentiate it second time, then the second time differentiation will give d2y, but means we can write over here d by dx of dy by dx, which we write as d2y by dx2, and this we can write as y double dash or f double dash x. Similarly, if we again differentiate it, then over here d3y by dx3, y triple dash and f triple dash x, and so on. So over here, this f dash x means derivative of f with respect to x. dy by dx derivative of y with respect to x. Okay? The same thing it is, the different way of writing it. So I think now you understand what is slope of a tangent and what is derivative. So now let us write the proper definition and go on. Now in derivative, in standard 11, it is required to know the derivative by first principle. Means the basic of the derivative is how to get the formula for the differentiation of different functions. So the base study is in standard 11 only. So in standard 11, if the question comes that find the derivative by first principle method, you have to do first principle method. And if it is not mentioned, that simply it is written find the derivative of or differentiate, then in that case no need of doing the derivative or the differentiation by the first principle method. Now I am talking about first principle method, but I did not tell what is first principle method. Now finding the derivative or the differentiation, this is the derivative definition, means with properly how it came, how the formula came. It means the whole explanation is called the differentiation or derivative by first principle method. So let us know the formula, or let us know how to find the differentiation of different functions by first principle method. Now, before knowing the formula or the derivation of the derivative of the different functions, I'll be writing the derivative or the differentiation of different functions by direct method. Why I am writing by direct method? Because if you are knowing the formula, suppose differentiation of sin x is cos x. Now, if the question is differentiate sin x by first principle method, or means find the derivative of sin x by first principle method, then if you are knowing that the answer is cos x, and then you are means sure enough that whatever I am doing, answer will be coming as cos x. So means before going to the first principle method, I am giving some formulas, some basic formulas by direct method, and then I'll be explaining the derivatives by first principle method. So let us go on. So derivative we will finding by first principle method, as well as we will be using direct method. So first few basic formulas I am giving by direct method. It's not compulsory that you means learn it by heart. With practice you will be able to memorize it properly. More practice will make you more acquainted with the formula. So we will be writing d by number 1 d by dx of x power n equals to nx power n minus 1. This power comes over here, and power of x, so this n comes over here, and this power of x is reduced by 1. Number 2, d by dx of root x is 1 by 2 root x. The same utilization of this formula I will be explaining also properly. D by dx of 1 by x is minus 1 by x square. Number 4, d by dx of sin x equals to cos x. Okay, I'm writing the trigonometric formulas at other place. Number 4, here I'm writing of e power x. D by dx of e power x equals to e power x only. D by dx of sin x, number 5, equals to cos x. Number 6, d by dx of cos x equals to minus of sin x. Number 7, d by dx of tan x equals to sec square x. Number 8, d by dx of cot x equals to minus of cosec square x. Number 9, d by dx of sec x equals to sec x into tan x. And number 10, d by dx of cosec x equals to minus of cosec x into cot x. Number 11, d by dx of log x, natural log, equals to 1 by x. Okay? Once keep in mind so that when we are doing derivation or differentiation by first principle method, the answer at least should be in our mind. So let us start derivative by first principle. So how these formulas came, that should be known, and that those formulas are derived in class 11 only. Yes children. Now before going to the first principle method, whatever we studied till now, I have written over here, let us know it, let us again revise it. So what is derivative? The first definition of derivative I have written over here, and the second derivative. Second definition of derivative over here. Now definition 1 of derivative. Suppose f is a real valued function and a is a point in its domain. Then the derivative of f at a is defined as f dash a equals to limit s tending to 0 f of a plus h minus f a by h provided the limit exists. Okay? Same thing whatever I explained over there, in place of x it is h, in place of x it is a over here. Okay? The definition which I explained over there, I have written in form of definition 2 of derivative. Suppose f is a real valued function, then the function defined as f dash x equals to limit s tending to 0 f of x plus h minus fx divided by h, where the limit exists, is called the derivative of f at x. Okay? Now this only definition is called the first principle of derivative. So I have written this definition of derivative is called the first principle of derivative. So whenever it is asked that differentiate by first principle method or find the derivative by first principle method, this formula only we will be using. So let us start and do few example sums. Find the derivative of 10x by first principle method. In solution part, we will be writing let fx equals to 10x. Then f of x plus h will be how much? 10 of x plus h. Okay? Then f dash x equals to limit s tending to 0 f of x plus h minus of fx divided by h equals to limit s tending to 0 10 of x plus h minus of 10x divided by h equals to limit s tending to 0 10x plus 10h minus of 10x divided by h. This two will be cancelled. Limit s tending to 0 10h by h, this h is cancelled, and we are getting limit s tending to 0 10. Now We have known from the limit chapter that if a constant is there, then limit h tending to 0 will give the constant value only, because over here no h. So where we will keep the value of h? So f dash x equals to 10, where, so we can write over here, therefore d by dx of 10x equals to 10. Okay? So let us go to one more example. Now over here children, f dash x, we have written fx is equals to 10x. So we can write over here d by dx of fx equals to 10. Both we can write. So the way of writing could be different, but the concept should be understood. So we have known now that the derivative of 10x by first principle method is 10. Find the derivative of, suppose the second example is x square by first principle method. So same thing we will be doing. Solution, let fx is equals to x square. Now by the direct method, clearly it is using nx power n minus 1 formula. The derivative of this will be coming as 2x. So that is that should be in our mind. If you want this correct definition, means if we are following the correct process, then obviously we will be getting the correct answer. But if the answer only is in mind, we will be sure enough that we have done correct. Now fx is equals to x square we have supposed. Then f of x plus h will be equals to x plus h whole square. Now f dash x equals to limit h tending to 0 f of x plus h minus of fx divided by h. ठीक है, equals to limit h tending to 0 x plus h whole square minus of x square divided by h equals to limit h tending to 0 x square plus 2 of hx plus of h square minus of x square divided by h. This x square is cancelled, and over here we will be taking h common. So limit h tending to 0 h 2x plus of h by h. This h and h is cancelled, equals to limit h tending to 0 2x plus of h. Now we will put the limiting value, that is h as 0. So we will be getting over here 2x plus 0 equals to 2x. And this is the answer. Now one more question. Number 3. Find the derivative of 1 by x by first principle method. So same process, everything we will be following. Let fx is equals to 1 by x. Then f of x plus h equals to 1 by x plus h. Now f dash x equals to limit h tending to 0 f of x plus h minus of fx divided by h equals to limit h tending to 0 1 by x plus h minus 1 by x divided by h equals to limit h tending to 0. Over here means we have to take the LCM and solve it. So x minus of x plus of h divided by x into x plus h, and this h we will be writing over here. So equals to limit h tending to 0 x minus of x minus of h divided by h into x plus h. Now this x is cancelled. So we are getting over here limit h tending to 0 minus of h by h into x plus h. H is cancelled. So we are getting limit h tending to 0 minus of 1 by x square plus hx. Now we will put the limiting value. So equals to minus of 1 by x square plus of 0 equals to minus of 1 by x square. So we put the limiting value where we find that the function, now the given function is not in an undefined form. Here wherever you put h is equals to 0, we will be getting an undefined form. So wherever the step where we find that the function is coming in the defined form, that is putting the limiting value, the function is coming in defined form, there only we keep the limiting value. This all we have done in the limit topic. So I don't think means explanation is required again. Now let us do the derivative of x power n by first principle method. Now before doing the derivative of x power n by first principle method, let us know the binomial theorem which you have already, means the expansion of two terms by binomial theorem which you have done in the binomial theorem chapter. Now we are knowing that x plus y power n, we are knowing x plus y power 1, we are knowing x plus y power 2, we are knowing x plus y power 3, means we are well acquainted with power 1, 2, 3 and suppose say power 4 also. But if it is coming more than power 4, then obviously we are using the binomial theorem. And binomial theorem says that x plus y power n equals to summation r equals to 0 to n NCR x power n minus r and y power r. Now this we can write as NC0 x power n, y power 0 I am leaving, plus NC1 x power n minus 1 y power 1 plus NC2 x power n minus 2 y power 2 plus NC3 x power n minus 3 y power 3 plus up to so on NCN x power 0, so that I am not writing, and y power n. So always keep in mind, power of x is difference of this one, power of x is difference of this one, and power of y is this one. Means NCR, then the power of y is r only. So over here the binomial theorem I have written over here with the expansion of x plus y. Now if in place of y we write h, then x plus h power n will become NC0 x power n plus NC1 x power n minus 1 into h plus NC2 x power n minus 2 into h square plus up to so on NCN h power n. Now we are knowing that NC0 equals to factorial n by factorial 0 into factorial n minus 0. Okay? So NC0 will be equals to factorial n by factorial n equals to 1. NC1 equals to factorial n by factorial 1 into factorial n minus 1 equals to n into factorial n minus 1 by factorial n minus 1, which will be equals to n. So we are writing over here NC0 as n. Now NCN also, you remember, factorial n by factorial n into factorial n minus n will be equals to 1. So NC1 and NCN, this only you keep in mind for the derivation of x power n by first principle method. The rest all we have done in detail in the binomial theorem, but right now only you remember NC0 is 1, NC1 is n, and NCN equals to 1. Only these three. Okay? Now let us proceed to find the derivative of x power n by first principle method. Solution. Let y equals to x power n. Then let y equals to fx also we can write. Y equals to fx equals to x power n. Then f of x plus h equals to x plus of h power n. Then dy by dx equals to y dash equals to f dash x equals to limit s tending to 0 f of x plus h minus of fx divided by h. This we are using frequently in all the sums. Equals to limit s tending to 0 f of x plus h is x plus h power n and fx is equals to x power n divided by h. Okay. So this we can write as limit s tending to 0. Let us use the binomial expansion which we have understood right now. So this I can write as nc0 x power n plus nc1 x power n minus 1 h plus nc2 x power n minus 2 h square plus up to so on ncn x power h power n and minus x power n divided by h. So limit s tending to 0. Now nc0 right now I have said it is 1. So I am not writing 1. 1 into x power n is x power n only. So x power n, and nc1 is n. So n into x power n minus 1 into h, ठीक है, plus nc2 x power n minus 2 h square plus up to so on, and over here I am writing h power n because ncn is 1 minus of x power n, ठीक है, divided by h. Now this x power n and this x power n is cancelled. Wait a minute. Is cancelled. So we are getting over here limit s tending to 0. Now in this you can see h square, h cube and so on till h power n is coming. So we can take h common. So h n x power n minus 1 plus nc2 x power n minus 2 h plus up to so on, and over here h is outside, so left in the bracket is h power n minus 1 divided by h. So we are cancelling this h, so we are getting over here, I am writing over here, equals to limit s tending to 0 n x power n minus 1, and the rest terms we have to write nc2, wait, I am writing, cannot fit over here, so I am writing here, equals to limit s tending to 0 nx power n minus 1 plus nc2 x power n minus 2 into h plus up to so on h power n minus 1. Okay, this we have got. Now we will put the limiting value. So all terms have h except the first term. So this we will be getting as nx power n minus 1. The rest terms, because of s tending to 0, will be 0. And this is the answer. That is, we can write over here d by dx of x power n equals to nx power n minus 1. So keep in mind this formula. Based on this, many sums we will be doing. So d by dx of x power n equals to nx power n minus 1. And this is an important question also. So practice it by your own as well. Now one more I want to do from the algebraic portion of root x. Okay. So same solution part. Let fx is equals to root x, then f of x plus h equals to root of x plus h. Therefore, let y equals to, so therefore dy by dx is equals to d by dx of fx equals to f dash x equals to limit s tending to 0 f of x plus h minus of fx divided by h equals to limit s tending to 0 under root x plus h minus of under root x divided by h. Now see over here children, if I put over here h is equals to 0, then it will be coming in an undefined form. So to make it in a defined form, so what we will be rationalizing it, because in limit also we have done, if root comes we used to rationalize. So let us rationalize it. So limit s tending to 0 under root x plus h minus of under root x by h into under root x plus h plus of under root x divided by under root of x plus h plus of under root x. So we are getting limit s tending to 0. This will become a square minus b square formula. So x plus h minus of x divided by h into under root x plus h plus of root x. This x is cancelled and we are getting limit s tending to 0 h by h into under root x plus h plus of root x. Again this h is cancelled and we are getting limit s tending to 0 1 by root x plus h plus of root x. Now it is coming in the defined form. If you put h is equal to 0, it will be a defined number. So let us put h equal to 0. So we are getting 1 by root x plus root x equals to 1 by 2 root x. Therefore d by dx of root x equals to 1 by 2 root x. So now let us go to derivative of some trigonometric functions. I think this will be question number 6. So let us start with suppose sin x. So in the solution part, let fx is equals to sin x. We can write let y equals to fx equal to sin x. Same it is. Let y equals to fx is equals to sin x. Then f of x plus h will be how much? Sin of x plus h. Okay? Therefore dy by dx equals to d by dx of sin x equals to f dash x equals to limit s tending to 0 f of x plus h minus of fx divided by h. Always write the formula and then the values equals to limit s tending to 0 sin of x plus h minus of sin x divided by h. Now over here we can use the formula sin of a plus b or sin a minus of sin b formula also we can use. Whatever you wish you can do. I am using sin a minus sin b. Definitely children you can get the formula the solution easily by sin of a plus b expansion of this one also, and then by hence by putting the limiting value. So let us use sin a minus sin b. So sin a minus of sin b equals to 2 cos of a plus b by 2 into sin of a minus of b by 2. So this will be equals to f dash x equals to limit s tending to 0 to cos of a plus b. A value is x plus h and b value is x. So x plus of h plus of x by 2 into sin of x plus h minus of x by 2 divided by h equals to limit s tending to 0. This is cancelled. So 2 cos of 2x plus of h by 2 into sin of h by 2 divided by 2. Now over here if I put h is equals to 0, then this will be cos of x and this will be sin 0. Sin 0 is 0. So we will be getting an undefined form. Sin means 0 by 0 form we will be getting. So let us use the limits definition means to a formula in which this term we will be getting reduced to a defined term. So what we will do over here, we will be using sin of h by 2 divided by h by 2 and limit h tending to 0 or h by 2 tending to 0. So that value will be equals to 1. So let us set in that form equals to limit s tending to 0 cos of 2x plus of h by 2 into limit s tending to 0 sin of h by 2 divided by h by 2. This 2 I have brought in the denominator, or what you can do into 2 and means divided by 2 into 2 you can do, but obviously this 2 will be cancelled with this 2. So just I have divided over here. So here now I can use 1. So we are getting over here limit h tending to 0 cos of x plus h by 2 into 1. Now we are getting a defined form. Now put h is equals to 0. So we are getting over here cos of x. Simple. So d by dx of sin x is cos x. Therefore d by dx of sin x equals to cos x. Or we can write sin x dash equals to cos x. Okay. So let us do the derivative of cos x now. Therefore, f of x plus h equals to cos of x plus h. Therefore, dy by dx equals to d by dx of cos x equals to f dash x equals to limit h tending to 0 f of x plus h minus of fx divided by h equals to limit s tending to 0 cos of x plus h minus of cos x divided by h. Now we will be using the formula cos c minus cos d or cos a minus cos b. Here again I repeat, cos of a plus b expansion also you can do and you will be getting the same answer. A minus cos of b formula we are knowing, cos of a minus of cos of b equals to minus of 2 sin a plus b by 2 into sin a minus of b by 2. If we don't write minus over here, then b minus a by 2. This is the formula. So now we will be using, therefore f dash x equals to limit s tending to 0 minus of 2 sin a plus b by 2 into sin a minus b by 2 divided by h. X is cancelled. So equals to limit, I am writing minus outside, limit s tending to 0 minus of 2, minus outside 2 sin 2x plus h by 2 into sin of h by 2 divided by h. Again the same thing what we did for the derivation of sin x. This sin h by 2 divided by h by 2 we will be doing. So we are getting over here minus of limit s tending to 0 sin of x plus of h by 2 into limit s tending to 0 sin of h by 2 divided by h by 2. By the algebra of the limits we have given the limit to both the functions. I mean over here sin of 2x plus h by 2 and sin of h by 2. So this will be equals to minus of limit s tending to 0 sin of x plus h by 2 into 1 equals to minus of sin of x. Therefore d by dx of cos x or cos x dash equals to minus of sin x. So let us do of tan x now. Of tan x, and number 8, 9 I don't remember. So let y equals to tan x, or let y equals to fx equals to tan x, then f of x plus h equals to tan of x plus h. Therefore f dash x equals to limit s tending to 0 f of x plus h minus of fx divided by h equals to limit s tending to 0 tan of x plus h minus of tan x by h. So we are getting limit s tending to 0 tan of x plus h minus of tan x divided by h. Now we have the formula of tan of x minus of y, but over here tan x minus of tan y formula we don't have. So we will be reducing tan to sin by cos term. So we can write this as limit s tending to 0 sin of x plus h divided by cos of x plus h minus sin x by cos x and divided by h equals to limit s tending to 0. Let us solve it, children. Sin of x plus h into cos x minus of sin x into cos of x plus h divided by h into cos x into cos of x plus h. ठीक है, equals to limit s tending to limit s tending to 0. Now over here sin a into cos b minus cos a into sin b. So we can write over here this as cos of x plus h into sin x. Same thing, 2 into 3 equals to 3 into 2 we can write na. But just to set in the form of formula, sin a into cos b minus cos a into sin b is sin of a minus b. So sin of a minus of b divided by h into cos x into cos of x plus h. So we are getting sin of h by h and limit s tending to 0 into limit s tending to 0 1 by cos x into cos of x plus h. ठीक है, so over here we can write 1. So 1 into limit s tending to 0 1 by cos x into cos of x plus h. Now a defined form we are getting, so let us put the limiting value. So we are getting cos x into cos x equals to 1 by cos square x equals to sec square x. Therefore d by dx of tan x equals to sec square x. ठीक है, now one or two more I want to do. Let us do of sec x. ठीक है, derivative of sec x with respect to x by first principle method. So same thing we will be doing. The steps are actually same. Let fx is equals to sec x, then f of x plus h equals to sec of x plus h. Now f dash x equals to limit s tending to 0 f of x plus h minus of fx divided by h equals to limit s tending to 0 sec of x plus h minus of sec x divided by h. Now sec a minus sec b we haven't done, so we will be reducing sec to cos form. So 1 by, let us first write the limiting value, limit s tending to 0 1 by cos of x plus h minus 1 by cos x divided by h equals to limit s tending to 0. Let us take the LCM and solve. Divided by h into cos x into cos of x plus h. Now cos c minus of cos d formula is limit s tending to 0 minus of 2 sin c plus d by 2 into sin c minus of d by 2. or if we don't write minus over here, then sine of d minus c by 2. Okay, divided by h into, I am writing over here, cos c minus of cos d equals to 2 sine c plus d by 2 into sine of d minus c by 2. You can write in terms of a and b also. Divided by h cos x into cos of x plus h. Now equals to, this x is cancelled. Now over here this h I can move over here to get sin h by 2 divided by h by 2, and that limiting value will be 1. So let us see, limit s tending to 0, sine of, here we can get x plus h by 2 divided by cos x into cos of x plus h into limit h tending to 0, sine of h by 2 divided by this h and this 2 brought in denominator. So we are getting over here this value as 1. So limit s tending to 0, sine of, let us put the limiting value also. So over here sin x by cos x into cos x and into 1. Now sin x by cos x is tan x and 1 by cos x is sec x. Therefore d by dx of sec x we can write as sec x into tan x. Similarly, other trigonometric ratios you will derive. Now keep in mind, for the trigonometric, whenever it is starting with c, the answer will be coming as negative. I mean d by dx of cos x starting with c equals to minus of sin x, d by dx of cosec x equals to cosec c is minus of cosec x into cot x, and sin cos d by dx of cot x c equals to minus of tan x. So keep in mind, the derivative of the trigonometric terms which starts with c is always negative. With that also we can remember. So to some extent the derivative of the basic functions I have done over here. Now let us know some rules of differentiation. So this is called algebra of derivatives of functions. Algebra of derivatives. Okay. So number 1, sum rule. First let me give the introduction, means let f and g be the two functions. Let f and g be two functions such that their derivative is defined and they have a common domain, defined in a common domain. Then number 1, for sum of two functions, means d by dx of f plus g equals to d by dx of f plus d by dx of g function. Means if we want to write in terms of x, that also we can write d by dx of f plus gx equals to d by dx of fx plus d by dx of gx. In this way also we can write. Means for the derivative of in the algebra of the derivatives, for the sum part, no confusion. it is the derivative of f plus g will be equals to derivative of f plus derivative of g. Now for difference, same thing. Is d by dx of f minus of g equals to d by dx of fx minus d by dx of gx. ठीक है. So if we write over here fx as u and gx as v, so we can write over here d by dx of u plus v equals to d by dx of u plus d by dx of v. We can write. Means if u I am writing as fx and v as I am writing as gx. Similarly, d by dx of u minus v will be d by dx of u minus of d by dx of v. ठीक है. Now for number 3, this is important children, for product. For product, d by dx of fx into gx, ठीक है, will be equals to fx into d by dx of gx plus gx into d by dx of fx. Now let fx is equals to u and gx is equals to v. Then d by dx of uv equals to u d by dx of v plus v d by dx of u. So this we can write as u v dash plus of v u dash. I think now you are getting. Means in terms of u and v, if we are writing, this is is written in some simplified form. Now this rule, that is d by dx of uv equals to u v dash plus v u dash, is also called Leibniz rule or Leibniz product rule, you can say. So remember over here, derivative of the product of the two functions is given by the this is also called the product rule. You can say product rule. Product rule. Okay. Now let us go for the quotient, or when the division of the two functions are there. So I am writing here number 4 for quotient form. D by dx of fx by gx equals to gx into d by dx of fx minus fx into d by dx of gx divided by gx whole square. Again in the simplified form, let us write, let fx equals to u and gx equals to v. ठीक है. Then d by dx of u by v equals to v d by dx of u minus of u d by dx of v divided by v square. This we can write in more simplified form as v u dash minus of u v dash divided by v square. ठीक है. So this is the quotient rule, this is the product rule, and quotient rule and product rule, children, keep in mind, do as more sums as you can. Obviously you will be in a practice to use this formulas frequently. Derivative, children, I forgot to do. Let us do that. Find the derivative of a constant function. Keep in mind the derivative of a constant function is 0. Constant function, say fx equals to a, by first principle method. So in this also we will be doing the same steps. Let fx equals to a. Then f of x plus of h will obviously be a only, because no x is over here, means in the function only a is there. So if you want to put, suppose over here fx is equals to 2. So if I put, if anyone is asking you find the value of f5, so f5 also will be 2 only. So I think you got whatever value of x we will put, the y value will always be 2. So if fx equals to a, then f of x plus h also will be a only. Therefore f dash x will be equals to limit s tending to 0 f of x plus h minus of fx divided by h equals to limit, the formula we always write, equals to limit s tending to 0 a minus of a divided by h equals to limit s tending to 0 0 by h equals to limit s tending to 0 0. Here 0 by h I am writing as 0 because h is actually not 0, h is tending to 0 obviously, and also I am not putting the value of h over here. Here the limiting value I am not keeping. 0 by any number I am keeping as, the value I am keeping as 0, because h over here is not exactly 0, it is tending to 0. So limit s tending to 0 0. Now over here no h term, so this will be getting as 0. So the limit, so the derivative of a constant term is always 0. So children, introduction of derivatives we have done. In the next video we will be doing 13.2. Till then, goodbye. Thank you.